See this problem. The line integral of vector A equal to minus yi plus xj over the closed path C. That path is a circle of radius r centered at the origin is option A 0, option B pi r square, option C 2 pi r, and option D is 2 pi r square. To solve this problem, we have to use the Green's theorem for the closed path. Closed path C, that is integral A dot dr equal to curl A dot k into A is k into dA. This is a formula we have to use. The vector A is given to you, so take the curl of A. L cross A equal to I j k dou by dou x, dou by dou y, dou by dou z. Then here we have to put minus y. Then the j component is x, k component is 0. If you take the determinant, say this is equal to I into dou by dou y of 0 minus dou by dou x of dou by dou z of x 0 minus j into, consider this, dou by dou x of 0 0 minus of minus into minus plus dou by dou z of y is also 0. So the only available component is k. K into, see here, dou by dou x of x is 1 minus dou by dou y of minus y is minus 1. Therefore, minus to minus plus, which is equal to 2k. This is the value of curl A. Now we may apply this value in our integral. Instead of curl A, we have to apply 2k. 2k dot k into dA, k dot k 1, so 2. Then if you take the integral of dA, we can get A. Area of the circle is pi r square. So the answer is 2 pi r square. Therefore, option D is correct. Now we'll go to the next problem. Let f is equal to y into I minus x into j. The line integral f dot dr when C is a unit circle centered at the origin is option A 0, option B 2 pi, option C minus 2 pi, option D pi. In this problem, we have to find out the value of integral f dot dr. The closed network is a unit circle, that means circle of radius unity, centered at the origin. Therefore, we can write x equal to cos theta and y equal to sin theta. In the case of circle, x equal to r cos theta, y equal to r sin theta, it is a unit circle, therefore r equal to 1. Now we have to find out the value of dx and dy. Dx equal to, if you differentiate cos theta, we can get minus sin theta into d theta. The same way, dy equal to cos theta d theta. Now we have to write down the value of dr. Dr equal to I into dx plus j into dy. This is the value of dr, which is equal to I into minus sin theta d theta plus j into the value of dy is cos theta d theta. Now we have to write down the value of f. F is equal to, see here, y into I. The value of y is sin theta. So sin theta multiplied by I minus x into j. The value of x is cos theta. So cos theta j. This is the value of f. Now we have to find out integral f dot dr, which is equal to integral of sin theta I minus cos theta j dot, then the value of dr, I into minus sin theta d theta plus j into cos theta d theta. I dot I 1, j dot j 1, I dot j 0, j dot I 0. Now we have to write sin theta I dot I 1 sin theta into minus sin theta d theta, which is equal to minus sin square theta d theta. Then cos theta with a negative sign, cos theta d theta with a positive sign, minus cos square theta d theta. If you take the negative sign outside, sin square theta plus cos square theta into d theta. These terms are to be present inside the integral. See here. Now we may write integral f dot dr, integral f dot dr, which is equal to sin square theta cos square theta is 1, so minus of integral d theta, which is equal to minus theta. In the case of circle, value of theta is 2 pi. So this is equal to minus 2 pi. Therefore, the answer is option C. Now we will go to the third problem. F is equal to xi plus 3yj plus 4zk. The flux of F through a cube of side A, cube of side A, centered at the origin, using Gauss theorem is option A 0, option B 3a cube, option C 9a cube, option D a cube. Now we have to use our Gauss-David theorem. The value of F is given to you. F dot ds. Gauss-David's theorem changes the surface integral into volume integral. F dot ds equal to div f into dv. Gauss divergence theorem changes the surface integral into volume integral. So f dot ds equal to div f dv. Then f is known to you. We have to find out the value of div f. Del dot f is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. This is the value of del operator. Dot, the value of f is 2x into I plus 3y into j plus 4z into k. See here, I dot I 1. Dou by dou x of 2x is 2 plus dou by dou y of 3y is 3. K dot k 1. Dou by dou z of 4z is 4. This is equal to 9. Therefore, f dot dv, which is equal to div f is 9 into dv. which is equal to 9 into V, which is 9 A cube. Volume of the cube is A cube because side value is A. Therefore, the option C is the correct answer. We will go to the fourth problem. This is third problem. Now we may go to problem number 4. Just vector identity we have to discuss. For a vector field A, the identity del dot curl A is option A del square A, option B 0, option C grade A, option D vector A. This is a vector identity. Die of curl of a vector is equal to 0. Del dot curl A equal to 0. You know that Gauss law in aerodynamics, die B equal to 0. Therefore, B equal to curl A, curl of vector potential. This is an identity, curl A. Therefore, the option B is correct. Die of curl of a vector is 0. This is the solenoidal condition, die B equal to 0. Then we'll go to the fifth problem. Stokes theorem relates a line integral over a closed curve C to option A, a volume integral over the surface bounded by C. Option B, a surface integral of the scalar field over area bounded by C. Option C, a surface integral of the curl of the vector field over the surface bounded by C. Option D. The gradient of the scalar field. This question talks about Stokes theorem. Option C is correct. A surface integral of the curl of a vector field over the surface bounded by C is a correct answer. Option C. This is our Stokes theorem. So we will continue the rest of the things in the next lecture.